Hi, my name is Albert Ali Salah. I'm with the Computer Engineering Department of Boğaziçi University, and I'm going to present you our joint work with Rıdvan Salih Kuzu and Koray Balcı, entitled Authorship Recognition in a Multiparty Chat Scenario. Let me first describe you the motivation behind this work. We have a project where we investigate verbal aggression and abuse during chat in social online games. These large social online platforms typically maintain moderator staff to help preserve the nice environment of the social game, and they have to answer user queries and complaints about verbal aggression, sexual harassment, and all kinds of aggression. While we do this by profiling the users normally, we also want to analyze the verbal content. Eventually, the aim of the project is to develop a tool to help the moderators in this arduous task. And in this specific paper, we ask the question, can we identify the people who have been banned from these websites, but return to the platform under a different identity? And we want to recognize these people by their conversations, practically. There is some work in the domain of authorship recognition where textual features and style is mined for patterns, and these are matched in a typical classification framework or authentication framework to recognize an author from a certain text. However, in this domain, we have a number of challenges. First of all, the chat messages that we deal with are in Turkish language, and there are not many tools for natural language processing in Turkish. Furthermore, the chat data are extremely messy. They contain abbreviations, sentence fragments, a lot of spelling mistakes, non-words, such as the words people invent to circumvent the blacklisted words. There is an absence of punctuation, and in general, it's very difficult to talk about a style of the user. Authorship recognition typically relies on a corpus of authors' works for training. Concatenating texts per author in one single text file is known as the profile-based approach. This large single file is used to extract properties of the author's style typically. A text sample from an unknown author is then compared with each author profile, and a suitable distance measure is used to find the most likely author. In this approach, features related with the variety of texts in the training corpus are not taken into consideration. Instance-based approaches, on the other hand, consider each text sample independently, hence differences in the training texts by the same author are not neglected. If we look at some of the commonly used features in authorship recognition, we have lexical features that include, for instance, total number of words or unique words, the ratio of short words to long words, word frequencies, and n-grams. We have character features that you look at the number of characters, the ratio of alphabetic characters to punctuations and emoticons, for instance. We can look at syntactic features, the function words, for instance, the number of paragraphs or sentences and lines, spelling errors perhaps even, and we can also look at semantic features, synonyms, hypernyms, semantic dependency graphs, or latent semantic analysis. To mention briefly some of the challenges arising from using Turkish as the platform is that Turkish is an agglutinative language, and most of the approaches in the literature focus on the English language, which is weakly inflected, whereas Turkish has very strong inflections. Here's an example. The Turkish word evlerinizden means from your houses. Actually, all these suffixes that a word can have, and a recent study shows that a Turkish root form may have more than 10,000 variations with all kinds of suffixes applied on it. With these challenges in mind, we have used the proprietary OK player abuse database in this study. This database consists of demographics, statistics, game records, interactions and complaints of thousands of players. The database was acquired from a commercial game over a 6-month period and incorporates roughly 100,000 unique players who played the game at least once. Now, OK is a social game, practically, is one of the classical games that existed in Turkey since the 16th century. And it's played between 4 people, and it has a very strong social aspect. And the online version duplicates this social aspect. Players have a multi-party chat window, and this window is used extensively. The game itself is extremely simple, but the chat data are extremely rich. We have selected a specific corpus from this huge database with around 1,000 users, and we restricted ourselves to participants who had vocabulary sizes more than 100 unique words, and certain amount of chat was required for each training session, because we also investigated the amount of training data usable for authenticating or recognizing a certain subject. Given a certain amount of chat data from a new user, we adopt the recentered local profile approach proposed by Layton and colleagues for modeling the proximity to the existing gallery of authors. This method uses a language profile in the calculation of a distance between an author and a document. In this formula, F1 and F2 are author and document profiles to be compared, and P is the language profile, which is extracted theoretically from the entire training set as an approximation to the absolute language. The natural language profile is impossible to obtain in its entirety, so we have to approximate this. We normalize profiles by using absolute distance of variation between each profile and obtain the second equation you see here. The most common n-grams method proposed by Kesheli and colleagues uses the relative distance between 2 documents or author profiles, and that serves as a basis for RLP. However, the most noticeable difference is that RLP measures the profile similarity according to most distinctive features, rather than the most frequently used features, using the standardized language profile approach described earlier. In our experimental protocol, we have used 3 different sets. The first set contains the entire 978 users. The second set was from 617 users, where chat sessions which have less than 140 characters are ignored. And the third set was obtained from a small number of users to check whether normalization by a Turkish NLP tool will bring anything to the analysis. To compute our features for each entry, we replaced the capital letters with small cases. Then we computed n by n sparse bigram matrices for each user. We tested 2 different alphabets. The first one had 32 characters, where you can see it on the table, the Turkish letters and the English letters. And the second one contained also some symbols, so it had 66 characters. During testing, we have systematically increased the number of instances per test user from 1 to 100 in order to understand how performance changes with respect to the number of samples per user. We also computed cosine similarity-based measures in addition to recentered local profiles. On this slide, you can see some of the results we obtained on test sets 1 and 2. The first set, the first 2 rows, is a 978 class problem, and we report rank 1 accuracy of identifying a user. The second set contains 617 users, so it's still a difficult classification problem. You see in the columns 1 to 10 chat sessions per user used in the training set, and as we increase the amount of training data, we obtain better results. With 10 chat sessions, if we're using the 66 character version of the approach, then we can obtain 74 or 75% rank 1 recognition rate with either RLP or cosine similarity. On the second set, we have less amount of sessions because we require that at least 140 characters are used per session. And then we have 78 to 79% accuracy obtained with RLP and CS respectively. We also conducted a third experiment on a smaller dataset where we use a Turkish normalizer, and that corrects most of the spelling mistakes. However, as expected, this kind of normalization removes discriminative information. So from 93.9% rank 1 accuracy on a smaller dataset, we obtain with normalization only 80% accuracy. So there's a significant accuracy drop after normalization. When we consider the entire chat sessions, we obtain a significant improvement for recentered local profile approach over cosine similarity measured with a t-test. Now we also did another experiment to inspect the effect of the number of chat returns or entries of a user per test case. And we used for this experiment the first set with 970 plus users, and used the recentered local profile approach. Now on the horizontal axis you see the number of chat entries per user, and the resulting identification rate is on the vertical axis. The curve stays relatively flat after 90-second entry, suggesting that about 100 chat entries per user is enough for giving us a decent accuracy. In this case, 77.5% rank 1 accuracy is obtained in about 1000 class problem. In conclusion, we have obtained with a simple approach around 75% rank 1 accuracy for a gallery size of 978 users. We have shown that normalization deteriorates the results, and the multi-party chat database is available for academic purposes upon request. This work is supported by the Scientific and Technological Research Council of Turkey and the Turkish Ministry of Development under 2 different projects. I thank you for listening. Because of unforeseen visa issues, I was not able to come and present this myself, and I know this is not very ideal. But for all technical details, I would like to refer you to the paper, and if you have any further questions, please contact me at salah@boneedutr. Thank you.